and good day, everyone. Welcome back to my YouTube channel. This is Sir Marcy, and our lesson for today is all about problem solving involving inverse variation. Are you guys excited? First, activity number one, direct or inverse. The instruction is read the phrase found at the right column in the table below. If the phrase is direct variation, write letter D in the answer column. If it is an inverse, write letter I in the answer column. If the relationship is neither direct nor inverse variation, write letter N. I'm going to give you only 30 seconds to answer this question. Timer starts now. Okay, time's up. Let's now answer the following problem. For number one, the number of hours to finish a job to the number of men working, the answer is I. It's an example of inverse variation. Number two, the area of a wall to the amount of paint used to cover it is letter D. That is an example of direct variation. Number three, the amount of water to the space that water did not occupy in a particular container, it's letter N. It's neither direct nor inverse variation. Number four, the distance of an airplane flies to the time traveling is an example of direct variation. And lastly, number five, the time spent in walking to the rate at which a person walked is an example of inverse variation. All right. If your score is 5 out of 5, that's great. It means that you are prepared in our next lesson. Let's go. Let's try to translate the following statement into mathematical equation. Use k as the constant of variation. Let's try to answer number 1. The number of persons n needed to do a job varies inversely as the number of days d to finish the job. The answer is okay, that is n is equal to k all over d. Next number 2, the number of petri plants n in a row varies inversely as the space s between them. Okay, the answer is n is equal to k all over s. Number 3, the mass m of an object varies inversely as as the acceleration due to gravity. That is m is equal to k all over g. Number 4, the base b of a triangle varies inversely as its altitude h. The answer is b is equal to k all over h. And last number, the length L of the rectangular field varies inversely as its width w. Okay, the answer is L is equal to k all over w. Solving inverse variation problem, we follow the same steps in solving direct variation problem. So the steps are the following. Number 1, write the correct equation. Inverse variation problems are solved using the equation y is equal to kx. Number 2, use the information given in the problem to find the value of k, called the constant of variation or the constant of proportionality. Number 3, rewrite the equation from step 1 by substituting in the value of k found in step 2. And lastly, use the equation found in step 3 and the remaining information given in the problem to answer the question asked. When solving word problems, remember to include units in your final answer. Let's try to answer example number 1. If y varies inversely as x and y is equal to 3 when x is equal to 4, find y when x is equal to 6. Our step number 1 is to find the correct equation. You can find it in the first statement. Y varies inversely as x means that is y is equal to kx. x. Next step is we're going to solve for the value of k. If you still remember in our past lesson, to solve for the constant of variation under inverse is you're going to multiply the two quantities x and y. Here, our x is 4 and our y is equal to 3. So we now obtain the value of our constant by multiplying 4 and 3. So the value of our k here, or the constant of variation, is 12. Next is we're going to rewrite the equation. From the original equation, y is equal to k all over x, we just simply plug in the value of our k here so that we will now have the new equation, or the equation of variation. That's y is equal to 12 all over x. Okay, for our last step, use the remaining information found in step 3 and to answer the question asked. In this case, we're going to find the value of y when x is equal to 6. So to solve for this one, or to find for the value of y, we will use the equation of variation, which is y is equal to 12 all over x. Since we're going to solve for y, we will just simply plug in the value of x here, which is equal to 6. So we now have y is equal to 12 all over 6. And what is 12 divided by 6? Y is equal to 2. So this is now our answer. The value of y when x is 6 is equal to 2. Proceed with our example number 2. If r varies inversely as s and r is equal to 100 when s is equal to 27. Find r when s is equal to 25. So step number 1, we're going to find the correct equation. Since the statement here is r varies inversely as s, that is simply r is equal to k all over s. So this is our equation. Next, we're going to find the value of k. So to solve for k, we simply get the product of r times s. Okay, so we know that the value of r here is equal to 100 and the value of our s is 27. So 27 times 100, our k is equal to 2,700. Next step is we're going to rewrite the equation by substituting the value of k we obtained in step number 2. From r is equal to k all over s, that is now r is equal to 2,700 all over s. Next is we're going to solve for the um, question asked. Since we already have our new equation, r is equal to 2,700 over s, we can now solve for r when s is equal to 25. So from r is equal to 2,700 all over s, we just simply plug in the value of s, which is 25. So that's now r is equal to 2,700 all over 25. So when you divide 2,700 by 25, our value for r is equal to 108. So the value of r when s is 25 is equal to 108. Okay, so that ends our lesson today. I hope you learned something new, and I hope to see you soon. That's all. Goodbye.